we have the volume of a sphere, because what's happening, a sphere is increasing at a rate of 2 inches per minute. That's given. We want to find how much the volume is changing when the radius is 6. So what we're going to do is we take this volume equation, derive it in respects to time. That's the first step. You always have an equation you're going to derive in respects to time. So that is going to be dv dt equals 4 over 3 pi. Take that out, and this is going to be 3r squared. And then what's the derivative of r? It's chain rule. The derivative of r, chain rule wise, is dr dt. Okay, there is my formula. Now, do you see the 3's canceling? Do you see this? A little bit easier formula. The 3's canceled. Okay, the question is asking, once again, find dv dt when r is 6 and the change of rate of the radius is 2. So we want dv dt. This is still 4. Pi is pi. Doesn't change. It's always pi, a certain number. What's r? R was 6. And what's dr dt? It's 2. So it looks like that becomes 36. So it looks like this is 4 pi times 36 times 2 is 72. And then 72 times 4 is 288. So dv dt is going to be, what was it again? 288 pi. And that would be inches, we're doing volume, right? So the inches cubed, volume is cubed, per, what are we talking about? Minute. It's good to put the units, not a necessity all the time unless they ask for them. Actually on the AP test, a lot of times they ask for units. So it's good to write the units, okay? Because they will ask for them at random times. So again, whenever you're doing volume, it's always cubed, and you're always doing it by the unit of time given. Don't forget the pi. It could be lost. Number 24. This cone is filled with water, and the water is, I believe, being leaked out or filled up. I believe it was saying on this cone, oh, you're filling the tank at a rate. So you're filling this cone up. So it's filling up. Got it? We know that dv dt is this. That's how fast we're filling the tank up with. I know my height is 8. I want to find dh dt. The problem is we have an r here. Do you understand if we derive this, we're going to have a dr dt, which is going to make problems for us. So somehow I need to change this original equation so it's all h's. And for some of you have to go back to geometry. There's something we have to think about here, and that something is properties of a right triangle. Why did I make that 5? Do you see this right triangle right here? Isn't that 5 because half of 10 is 5? Now, do you understand there's a proportion here? You have your radius to height, correct? Do you understand this is your radius to height? Is what? Isn't that a proportion of 5 to 12? Now, going back to geometry, do you remember, no matter what the radius is, say that's your new radius, do you understand it's always going to be radius to height proportion? With the right triangle, say this is your height, it's always going to be the height to radius. It's in proportion on a right triangle, no matter what. As long, because this tank, it does not change shape. Got it? The tank is always the same shape. You're filling it up. So this right triangle will always have a proportion of rate to height. And in this situation, it's 5 to 12. What again did I want R to become? H. Could I solve this equation for R in terms of H? What I mean by that is, do you remember cross multiply? If I cross multiply. Now, did I want to solve for H or R? Which one did I want? I want to make it an R equals, so it's kind of hard to remember this. But you want to divide by 12. So R equals 5 over 12H. Why did I want to do that? Because if I go back to my original formula, V, pi, I want to replace R with 5 over 12H. You see now, this equation, instead of R, I now have it in terms of H. It's called substitution. We made an equation due to proportions, found R in terms of H, and now we have an equation in all H's. Could I have done this later in the problem? Yes, it just would have made it more complicated. It's best sometimes to look at your equation and transfer it, looking what's given. You always want to find out what's given first, but looking what's given, you want to change your equation so if there's any extra variables, those variables disappear, and they're in the variables you want to do the problem in. Okay, what does all that mean? Looks like this is going to end up being pi. When you square this, do you understand that's going to be 25 over 144 h cubed over 3? All that saying, all that means, woo, your volume ends up being 144 times 3, $432. So this one's going to be 25 pi h to the third over 432. That is my new volume formula in terms of only h. Can I derive this and I'll have dH dt, I will have an h, I will have dV dt. Can I plug everything in, find dH dt? This is where it gets a little bit more complicated. So we now have dV dt is equal to, can I take the 25 pi 432 all out and make this simply 3h squared dH dt. That is the equation I want to use right there. This is my new equation. This is a pi. Can I plug everything in I have right here, find dH dt? So we're taking this now, coming up here. Looks like dV dt is 10. I have 25 pi 432. I have 3 times 8 squared. And I have dH dt. Okay. If I solve that, I'm getting some big numbers, and I don't have a calculator on me. But when you end up solving for dH dt, I'm just going to give it to you. dH dt ends up being 9 over 10 pi, and dH dt is in what's the unit measure? dH, h is just feet, and the unit is minutes. Now, if you again solved all this down, divide the 10 over, and so forth, this is what I believe you would get according to my notes.